Hey guys, this is Mrs. Brookshire. This is section 9.2, test about a population proportion. A significance test can be used to test a claim about a population parameter. Section 9.1 presented the reasoning of significance tests and the idea of a p-value. This section describes how to perform a significance test about a population proportion. So there's a definite set procedure for performing a significance test, and the first part would be checking the conditions for the performing a significance test about a proportion. Okay, so these are the things, and some of these are going to look familiar. The first one, random. This is kind of different. We didn't do this before, but the data has to come from a random sample from the population of interest. So you have to have randomness. So usually you just check the problem and it'll say you have a random sample. Independent, which we have, or the 10% condition, which we've been doing here for a couple of chapters. So when you sample without replacement, you've got to do 10 times n is less than capital N. 10 times the sample size has to be less than the population size. You also want to do the large counts, showing that you have normal. So both n times p naught and n times 1 minus p naught are at least 10. So the p naught is from the hypothesis statement. You know how you have h naught or h sub 0 or h naught? P naught, that specifically does come from the hypothesis statement, so that p value there. Because we assume the null hypothesis is true when performing a significance test, we use the parameter value specified by the null hypothesis, denoted p naught, when checking the large counts condition. Okay, so we're going to kind of go through this first one, and all we're going to do is check the conditions. Okay, so here's the problem. According to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out a test at the alpha equals 0.05 significance level. So as you read through the problem, what the p equals 0.25 is the claim, and the principal thinks that her students at her high school, that it would be less than 0.25. P is the true proportion of all students at the school who have a part-time job. The administrator selects a random sample of 200 students from the school and finds that 39 of them have a part-time job. Check the conditions for performing the significance test are met. So we've got to check those three conditions. The first one is random, and that does say, we kind of mentioned that, there's random. So random sample of 200 students, so that condition is met. The next one is your 10% condition, or also shows that you have independence. So 10 times 200 is less than or equal to all the students at this large high school. And then the last condition is your normal condition. So when you are doing or checking this condition, you always use the number in your hypothesis statement. So you're going to use 0.25 for your p naught. So it's 200 in the sample times 0.25, and obviously 50 is greater than or equal to 10, and then 200 times 0.75, 150 is greater than or equal to 10. So on that particular problem, we were just checking the samples. You do need to do that every time you are performing a significance test. Okay, you guys will remember this statistic. A standardized statistic measures how far a sample statistic is what we would expect if the null hypothesis were true in standard deviation units. So what we're going to do every time is you're going to find your z-score. This is basically your z-score, okay? So the z is your standardized test statistic. So if you ever have a question that says, what is the test statistic? It's your z value or your z-score. So this is your statistic, so you get that from your sample. And then this is from your null hypothesis, 0.25 would go here. And then your standard deviation of the statistic. Now the weird thing about this is, and this is something I'm going to keep saying this is the only place right here that you actually use the statistic. This comes from the hypothesis statement, and this you use that value from the hypothesis statement as well. So you're familiar with this. This is actually what we're doing. So what we're going to do is, let's look at this problem again. And we're going to go through, and it says in the preceding example, it's the same problem about the workers in high school. So part A says, explain why this sample result gives some evidence for the alternative hypothesis. Okay, so all we're doing is looking at the sample. The sample is 39 out of 200, which is equal to 0.195. Why would that give some evidence against the null hypothesis? Well, because this value is less than 0.25. So it's less than the national proportion. So this would give, the question is, why does it give some evidence for the alternative? Because this is falling right into place of what the alternative is. Part B, calculate the standardized test statistic and the p-value, and then part C, we're going to make a conclusion. So we've already had the conditions met, so now we're going to do z equals p hat minus p, and then there's your standard deviation, because this is a sample. This is the only place you use your statistic. So that's 0.195. This comes from your hypothesis statement. And when you find your standard deviation, you also use that value from the hypothesis statement. It seems kind of odd, so make sure that you pay attention to that. This is the only place that you actually use that statistic. Hypothesis statement, and then this is from the hypothesis statement. So then you get z equals negative 1.8. That is our test statistic. Now, once you have that, you can go do your normal curve, which I drew out. And don't forget, we are using this z value. So your mean is 0 here. And when you do norm CDF, it's going to be negative 1e to the 99 is your lower bound, negative 1.8 is your upper bound. Your mean is 0. And you will use the standard deviation of 1 because you are using the test statistic. And when you do this, like, we had a point where we were kind of skipping this and just doing normal CDF and putting the mean and the standard deviation in. But on these problems, you will not do that. You will go find your Z, and you will use 0 and 1 when you do your normal CDF. What that is giving you is your p-value or your probability, okay? So when we look at this and we compare it to what's our alpha value, our alpha value is 0.05. So think about this compared to 0.05. Does everybody agree that this is less than 0.05? So that means that our P is low. And we had said in the last section that if your P is low, you're going to reject the null hypothesis and conclude that the alternative is true. So let's write out our conclusion. Since P is equal to 0.0359, which is less than the alpha value of 0.05, we reject the null hypothesis. You always write that in your first sentence, and then your second sentence will be in terms of the alternative. Since we are rejecting the null, we are saying that we have convincing evidence that the true proportion of all students at this high school who have a part-time job is less than 0.25. So make your statement, and then if you reject it, we have evidence for this. If you fail to reject it, we have evidence that we don't have evidence to conclude the alternative. Okay? All right, so the next problem we're going to do, let's talk a little bit about we're going to do another problem like this. And then I'm going to let you guys try one on your own and check it, and then we're going to talk about some other things. Okay, notice that we did not include an option B to use technology to find the desired area without standardizing. When performing the normal calculation in part B of this example, that's because you always are required to give the Z, or the standardized test statistic, and the p-value when performing a significance test on the AP exam. So you've got to find your Z. You're going to go do normal CDF. You're going to use 0 and 1 as your mean and standard deviation, and that's going to give you your p-value. Another exam tip, it says you can use your calculator to carry out the mechanics of the significance test on the AP exam, but there's a risk involved if you just give the calculator answer with no work, and one of the more of your values are incorrect. You'll probably get no credit on the do step. If you opt for the calculator only method, be sure to name the procedure, one sample Z test for a proportion, and to report the standard statistic, which is Z, and the p-value. So there is a way to put this on the calculator, and we're going to talk about that later, or probably your AP stat teacher will, but right now we're going to do it, just kind of go through and do it the long way, okay, with everything. All right, this test that we are doing on this proportion is called a one sample z-test for a proportion. Okay, so one, it's only one sample. Two, we're using a z-score, so that's a z-test, and then it is a proportion. Okay, suppose the conditions are met to perform the test. You have to compute the test statistic, which we talked about. Don't forget that's the only place that you use the sample statistic. This is from the hypothesis statement. This is from the hypothesis statement. Okay, these two right here are called one-sided tests, and this is called a two-sided test. So these are all, you pretty much do the same way. We're going to go do one more one-sided test. I'll let you practice one, and then we're going to do a two-sided test. Then we're going to talk about what's better, a confidence interval or performing a hypothesis test. Okay, so this example here is one that we had done previously about the potato chip producer, and it's the same problem that if, they said if 8% is sort of the magic number, and if it's greater than 0.08, they're going to send it back, and otherwise they're going to use them all. So let's get to right here. The potato chip producer has just received a truckload of potatoes from the supplier. The supervisor selects a random sample of 500 potatoes from the supplier. A supervisor selects a random sample. An inspection reveals 47 of them have blemishes, okay? And we're going to go through, is there convincing evidence at the alpha equals 0.10 level that more than 8% of the potatoes in the shipment have blemishes? Okay, so when you read a problem like this, is there convincing evidence at blah, 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 this is how you know you're doing a hypothesis test. Like, confidence interval we just did in the last chapter, it'll say, hey, what I want you to do to make a 95% confidence interval. If you see a question like this is kind of what gives it away that you're doing a hypothesis test. All right, so let's work through this whole thing together. So the first thing I'm going to do over here is I'm going to go figure out what my sample, what my p-hat is, since I'm reading through it. So it's 47 out of 500. Okay. And 47 out of 500 is 0.094. I'm going to go on. I know I'm going to need that here in just a minute, so I'm going to go on and calculate that. All right, we're going to go through the whole process on this problem, and then I'm going to let you guys try one on your own and check it, and then we're going to go to a couple other things that we need to talk about. So you've just got to memorize what you need to do. The first thing is like all your statements, like you're going to state. And you don't have to write this down. You can just do it. So we have to state the null and the alternative hypothesis. So the null hypothesis is that P is equal to 0.08. Okay. The alternative hypothesis is that P is greater than 0.08. Whoops, greater than 0.08. Sorry. Okay, so that's one thing you need to have in your statements. Okay, the second thing is you're going to actually state what P is. What is the parameter? Or what is it that you are, working with in this problem? We're trying to find the true proportion of potatoes in this shipment with blemishes. Okay, that's our parameter. That's what this whole problem is about. The next thing you need to have in your statement is what's the name of this procedure. Okay, that's what we were talking about just now. This is a one sample, and it's a z-test because we're doing a hypothesis test for proportions. And I usually go on and say at alpha equals 0.10. Oops. One sample z-test for proportions at alpha equals 0.10. So that's the first thing you need to do is you need to make these three statements. You need to say what the hypothesis statement is. You need to say what P is, what's the parameter, and you need to state what procedure that you are doing. Okay? The next part is kind of like your plan and your do. All right, so we know that we need to go through and we've got 3 conditions that need to be met. We've got to have random, we've got to have independent or a 10% condition, and we need to have normal. Okay, so let's go through and make sure all these conditions are met. So when you read this, it says right here that we do have a random sample. So I'm just going to write random sample selected. It is stated in the problem. Okay, so that condition has been met. Independent, 10 times n is less than or equal to capital N. So there are 500 in the sample, and I'm pretty sure that 5,000 is going to be less than all the potatoes in the shipment or in the truck. Let's just say in the truck. Okay, so that one's met. And then the last one is normal. So this is where we do the n times, don't forget it's p naught is greater than or equal to 10. And then n times 1 minus p naught is greater than or equal to 10. So don't forget, you're not using the p hat. You're actually going to be using your 0.08 from your hypothesis statement. And guys, that's equal to 40, which is greater than or equal to 10. And then we're going to do 500 times 0.92, which is 460, which is greater than or equal to 10. So all 3 conditions have been met. The next step would be to go on and do your procedure. So it's z equals, and then we're going to do the x is 0.094. Well, that's really your p hat. Minus, that's from the hypothesis statement. And don't forget, this is also from the hypothesis statement. The only place, I keep saying this, you use your statistic is right here. So this is 1 minus 0.08, which we'll just put 0.92. And that's still divided by 500. So when you get your z, that's equal to 1.15. Okay? If you're ever asked, this is your test statistic. If they ever say, hey, what is the test statistic? It's the z. Okay, now I'm going to kind of draw this out. And this is 1.15. Now don't forget on this, because we're using the z, our mean is 0. And this is what we're trying to determine, is what is that probability. That's going to be our p-value. So we are going to use norm CDF. And it's 1.15, 1 e to the 99. Our mean is 0 and our standard deviation is 1. And again, we do use that because we are using that test statistic. So when you go through in your calculator, you will get 0.1251, and that is our p-value. So what we're going to do is we're going to take and we are going to, I'm going to kind of box these in. We're going to compare that to our alpha, which is 0.10. So when you look at this and you compare it to your alpha, that is higher than that. So the last section we said if the p is low, you reject the HO or the null hypothesis. Well, this p is not low, so therefore we have to fail to reject it. So you have your, the last thing you're going to do is your conclusion. I think I'm just going to write that right here. Okay, so our conclusion. Remember when we write our conclusion, we're going to say, since p equals 0.1251 is greater than alpha equals 0.10, we fail to reject the null hypothesis. Okay, so that's going to always be your first statement. And then the second statement is you're going to write your conclusion in terms of the alternative. So since we are failing to reject the null, we're not really saying it's true, but we have to fail to reject it. We do not have convincing evidence for the alternative. So that's what you're going to say. There is not convincing evidence. There is not convincing evidence that the true proportion, so think about what your parameter is, that the true proportion, you're including that in your conclusion, of blemished potatoes in the shipment, and the shipment is greater than 0.08. So that is my conclusion. So again, the first sentence is always going to be whether you reject it or you fail to reject the null, and then your conclusion is always stated using the alternative. So there is not convincing evidence that the true proportion of Flemish potatoes in the shipment is greater than 0.08. All right, so what I'm going to let you guys do, go to the next page, and I want you to go through this whole procedure again, and then I want you to, with the next problem, and then we'll kind of look at the answer, make sure you're good, and then we're going to do a two-sided test. There is one AP exam when a significance test leads to fail the null, as in the preceding examples. Be sure to interpret the result as we don't have convincing evidence for the alternative, and that's what we did. Saying anything that sounds like you believe the null is or might be true is going to lose 2 credits. So you never make a conclusion. You just say you either accept or fail to, or reject or fail to reject, and then your conclusion is always in terms of the alternative. So what I would like for you guys to do is go through and do this check your understanding. Take a minute, stop, go through the whole procedure, and then check it with my answers. Okay, check and see. Do you have the hypothesis statement correct? State what the P is. And it's a one sample z-test for proportions. And you could put the alpha at alpha equals 0.05. I usually do put that there. I checked to see if it was random, independent, normal. I did my z equals. Don't forget this is the only place that your p hat goes. This is from the hypothesis statement. This is from the hypothesis. I got a z equals to 2.06. Okay, if you need to draw that out, I usually do. So it's this and above. So there's my norm CDF. There's my p-value. When you compare this p-value with this alpha, this is less than this. So if the p is low, and it's low compared to this, we're going to reject the null. So that's what we have as our conclusion. Since the p is equal to that is less than that, we will reject it. And so then we have convincing evidence that the true proportion of teens who say they have sent or posted suggested images of themselves is greater than or equal to 0.2 or 20%. Okay? All right. We're going to go on down now. We're going to talk about what is a two-sided test, and then we're going to practice that together. There's actually only one small adjustment, and then we're going to talk about like what's more effective, a hypothesis test or a confidence interval, like which one shows the most information. A two-sided test. The free throw shooter part-time job in blemished potato settings involve one-sided test. The p-value is one-sided about a proportion, and the area is specified by the alternative. So it's either less than or greater than. In a two-sided test, this is when you have a two-sided test. If your alternative is not equal, you have to find the area in both tails to get the p-value. So let me take you back just a minute to the page before. So if you have greater than, you have your value, and that's one-sided. If you have less than, you get your z-value, and it's one-sided. But if you have not equal to, that's where you have a two-sided test. Okay? So we're going to walk through this one. And like I said, there's only one tiny thing that's different. Okay, according to the Centers for Disease Control, the CDC says 68% of high school students have never smoked a cigarette. The student wonders whether this result holds true in her large urban high school. For the project, she surveys a simple random sample of 150 students from her school. She gets responses from all 150, and 90 say they have never smoked a cigarette. Okay, so I'm going to go on and put down my sample proportion is 90 out of 150. And guys, that's equal to 0.6. Is there convincing evidence? This is how we know that we're doing a hypothesis test, that the CD's claim does not hold true. Okay, as you're reading through this, we're getting ready to write down the hypothesis statement. It says that she wonders whether this is true. It doesn't say, hey, I think more than people than that have. Or, hey, I think less people. It just says that she wonders if it's true. So that's going to be a two-sided test, okay, because it's going to be not equal in the hypothesis statement. So the CDC, the claim is 0.68. Her thought is, or what she wants to prove, is that it's not equal to 0.68. This is when you have a two-sided test, okay? Still, it's a one sample. Oh, let's write down what P is. P is like, what is the parameter? The true proportion of all students in her high school, her school, who would say they have never smoked a cigarette. So that's the true, or that's the parameter, okay? And then the last thing, what's the procedure? This is a one sample, and we're using our Z test. We're doing a hypothesis test for proportions at alpha equals 0.05. All right, so there's our statements that we have to make. Now we're going to go check our conditions. We have random, which up here it does say random sample. So random, I'm just going to state random. You don't have to write this. You can just write, if you would like, random sample, which is random. Okay, then we're going to check independence. That's your 10% condition. So 10 times 150 is 1,500, and I'm going to tell you that is less than all students in a large high school. In large high school. And then the last thing we do have to check is, so this is good, and now we have to go check normal. Okay, so normal, again, with a proportion, the way you always check normal is, don't forget though that you are using from the null hypothesis. It's greater than or equal to 10, and then n times 1 minus. So we have 150 times 0.68, and then 150 times 0.32. We need to check it out and make sure that both of these are greater than or equal to 10, and they are. So we do have a normal distribution, normal sample here. Okay, the next part, we're going to do Z equals. Our 0.6 goes here, only place this statistic goes. 0.68 here, and then down here, you will use the 0.68, 0.32 over the 150. Okay, you will get Z equals negative 2.10. There's our test statistic. Now, don't forget on this one, when you draw this out, this is what helps, I think, when you draw these out. You will realize that this is a two-sided. Okay, so I want you to draw out both sides. We know that these two probabilities here are equal. Okay, so we're going to go on and we're going to calculate the probability of this. So we're going to do norm CDF. My lower bound is negative 1e to the 99. Then we have negative 2.1. Then we have 0 and 1. So we do get our p-value of 0.01786 times 2. Now, why are we going to, this is what we need to do that's different. Once you find this probability is the same. So all you do is take your p-value and multiply it by 2. So when you have a two-tailed test or two-sided, that's what you're going to do, okay? That's my p-value, 0.0357. So that's the only difference if you have a two-tailed. So whatever you get, you might get this or you might get this. Whichever one you get, you find the probability, and then the other one's the same. Okay. So that's our p-value. When we compare it to this is lower than our alpha. If the p is low, we're going to reject the HO, or the null hypothesis. So our conclusion, it's the last thing we need to do. We're going to say, since p equals 0.0357 is less than alpha equals 0.05, we will reject the null hypothesis. And so what does that say? So if we're rejecting this, then we have convincing evidence that this is true. So we're going to say that the alternative is true. We have convincing evidence that the proportion of students at her high school who say they never smoked a cigarette differs, or you can say is not equal to, from 0.68. And that is what you do if you have a two-sided. You just have to pay attention and don't forget. A lot of people forget. You got to look back up here and remember that's not equal, so it's two-tailed. Okay, last page, we are going to talk about what is better,